In the previous video, we have already defined a scalar product of two vectors. Let us again write. Let A and B, vector B, be two vectors and theta be the angle between them. Then the scalar product of two vectors denoted is denoted by a vector dot b vector, and it is defined as a vector dot b vector is equal to modulus of a vector modulus of b vector times cos theta, which can be simply written as a b cos theta. Here a is equal to modulus of a vector and b is equal to modulus of b vector are magnitudes of a vector and b vector respectively. And we have also discussed the special properties as if a vector is parallel to b vector, then a vector dot b vector is equal to modulus of a vector times modulus of b vector. This one is the first one, and the second one, if they are perpendicular to each other, at that time a vector dot b vector is equal to 0. So these two special cases we already discussed in previous video. Now here we are going to discuss about the alternative method. So before going to alternative method, to define alternative method, we have to know certain terms such as triangle law of vector addition, triangle law of vector addition. Let us draw a figure. Let us draw a triangle first of all. So here let us take a vector from a to a displaces from a to b and b to c. Here we have two vectors ab and bc. Vector ab displaces from a to b, and vector bc displaces from b to c. Now if we will add these two vectors, then it means that it displaces from point a to c, which is written as a vector ac, and this one is called resultant resultant vector. In another word, we can say it is triangle law of vector addition. Now the another representation of any vector in terms of I and j. What is I and j? I is a unit vector along with x-axis, and j is a unit vector along with y-axis. So let us, here we are going to represent any vector in terms of I and j. So how we can represent it? Let us see. If I and j are unit vectors along x-axis and y-axis respectively, then I vector is unit vector, so we can write is along with the x-axis, so we can write 1 0 in column form, and j vector is equal to 0 1 in column form. Then the vector a vector, say, and its components, x components and y components are, say, x and y can be written as a vector is equal to xy, x 0 plus 0y. Now let us take x common, and let us take x out, then here remain 1 0, and here y 0 1, and x and 1 0 is represented by I vector and plus y j vector. So this way we can represent any vector in the ij form. Now let us look at this point. Since I and I are parallel vectors, so theta, that is the angle between I and I, must be 0, and since I is unit vector, so its magnitude must be 1. Now I vector dot I vector is equal to modulus of I vector times modulus of I vector times cos 0 degree. As we know that the a and b are the two vectors, then we can write modulus of a vector times modulus of b vector times cos theta, where theta is the angle between a and b vectors. So now the modulus of I is 1, modulus of I vector I is 1, and cos 0 is equal to 1, cos 0 degree is equal to 1. So we have I times I is equal to I dot I is equal to 1. So similarly we can get j vector times vector j is equal to 1. And another point, since I vector and j vector and they intersect each other by making angle 90 degree, so angle between I and j, I vector and vector j are perpendicular to each other. Perpendicular is also known as the orthogonal. So theta is equal to 90 degree. Then I vector dot j vector is equal to modulus of I vector times modulus j vector, and angle between them is 90 degree. 1 times and cos 90 degree is equal to 0, so we get 0. Similarly j dot I also we get 0. So at last, hence I vector dot I vector is equal to j vector dot j vector is equal to 1, and I vector dot j vector is equal to j vector dot I vector is equal to 0. So now we have discussed that any vector can be represented in ij form, and we also seen that the I vector times vector I is equal to 1, ij is I times I vector I dot j vector is equal to 0. Now let us define the alternative method. That is, now we are going to define the alternative method to define a scalar product of two vectors. Say one vector is a vector and its components are x1 I vector plus y1 j vector. It can be written as in the form of ij. And the another b vector x2 I vector plus y2 j vector. Then a vector dot b vector is equal to x1 I vector plus y1 j vector times x2 I vector plus y2 j vector. Now let us multiply x1 x2 I vector dot I vector plus x1, now this one with y2, x1 y2 I vector dot j vector plus, now this one to this one, y1 x2 j vector dot I vector plus y1 y2 j vector dot j vector is equal to x1 x2, as we know that the I vector dot I vector is equal to 1 plus x1 y2 times ij I dot j I vector dot j vector is equal to 0, and y1 x2, and it is also 0, and y1 y2 times 1, it is j dot j is 1. So the now here x1 x2 plus 0 plus 0 plus y1 y2, that is x1 x2 plus y1 y2. So which is another definition for scalar product. Also, let us express the angles in components form. So here a vector dot b vector is equal to x1 x2 plus y1 y2. Modulus of a vector is equal to root over x1 square plus y1 square, and modulus of b vector is equal to root over x2 square plus y2 square. Now angle between a vector and b vector is theta, so we can write cos theta is equal to a vector dot b vector by modulus of a vector modulus of b vector modulus of a vector times modulus of b vector. A vector dot b vector is equal to x1 x2 plus y1 y2 by root over x1 square plus y1 square times root over x2 square plus y2 square. So this is the angle between two vectors in the form of components. So this is the last one. Thank you for watching this video. And also I have to say that you must subscribe my channel and also like it. Thank you very much.